Okay, so section 3.4 is all about parallel and perpendicular lines. And before we even actually write anything, I want to make sure that we know what parallel and perpendicular are. Parallel, perpendicular. Wow, my handwriting is so bad on this thing. So we have parallel and perpendicular lines. So remember, parallel lines are lines that look like this. They never ever cross, and they are denoted by a little triangle thing or arrow or whatever that goes on the actual line itself. So remember, parallel lines are lines that look like this. They can also have arrows that look like this. It doesn't really make a difference what those arrows look like as long as they're not on the end of the line and they are somewhere on the inside of the line. Perpendicular, and this is a symbol that a lot of people don't really know because I get asked that question a lot. It's an upside down capital T. So perpendicular looks like that, and what it means is it is two lines that cross, and they cross at a perfect 90-degree angle. So this is something, again, that I'm hoping you guys kind of remember and know from either earlier math years of your life or just from this year, but parallel and perpendicular look like that. There is a symbol for parallel. I could say that like line AB is parallel to line B, I can't see B, to like line CD. So if I see this thing right in here, where it's two lines that look like that, that is just the shorthand notation for parallel. If I do the same thing where I said like AB is perpendicular to BF, this means perpendicular. So the way that I would draw that is I would say AB looks like this. And then BF would be a line that looks like this. And then it would just be saying that those two things are perpendicular to each other. Okay, they cross at a 90-degree angle, so that means where they 2 points intersect is a 90-degree angle. So that's just something to kind of think about, something from for future.
Can you draw the other one?
That one is just, you have AB. And then CD. So this one would have arrows because it's got arrows on the end. And then CD.
I thought it was the same exact to B. I was mistaken.
And then it would have, I would put these little marks on here just because since my drawing is not perfect, that tells me for sure that my lines are going to end up being parallel to each other. All right. Any questions or concerns or issues with that? All right. So this is the actual start to the section 3.4 worksheet. Okay. This thing right here, I'm going to put in quotation marks, is kind of like a theorem. And this thing right here is the proof of that theorem. So this is just basically more proofs that we can work our way through and understand how and when and how to prove certain things. Okay. So I'm going to go through everything on the front of this page. That way we can work together. All right. Give me 1 second. So the first one is called the linear pair perpendicular theorem, and I'm not gonna force you to remember this at all, but it is called the linear pair perpendicular theorem. So this has just a really long word, but it's just one thing that I kind of want you to understand works. And basically the biggest idea behind this entire thing is seeing another proof. As many proofs as you guys can see, that is as good as it gets. Okay, so if two lines intersect to form a linear pair, come on. If two lines intersect to form a linear pair of congruent angles, then the lines are perpendicular. Okay? So what this means, and this is kind of tricky because it's a hard thing to kind of look at, but it's saying that if two lines intersect to form a linear pair, if you look at this picture right here, line A and line B are intersecting, right? These two lines right here cross. And since those two lines right here cross, they're going to create linear pairs. And by linear pairs, I mean right here and right here. Those two lines, or those two angles, are a linear pair. They're right next to each other. But if you look at what's happening, it also tells us that angle 1 and angle 2 are the same. So right now, based on what I see in this picture, I know that angle 1 plus angle 2 has to equal 180. So I know that angle 1 and angle 2 are going to equal 180. But I also know that angle 1 is equal to angle 2. So if angle 1 and angle 2 are the exact same number, and they both add up to 180, then how big does angle 1 and angle 2 have to be? So this is a legitimate question. If angle 1 and angle 2 are the exact same number, and those two numbers add up to 180, how big does angle 1 have to be?
Angle.
Say it again.
90 degrees.
So this is saying that angle 1 is 90 degrees. Oops, that's not what I want. Angle 1 is 90 degrees. So if I know that angle 1 is 90 degrees, that should make sense right here. If I know I just proved or showed that angle 1 is 90 degrees, that means that A and B are going to be perpendicular to each other. That's what this theorem means. All right, so now let's go through the actual proof of it because we just talked it out up here. But let's go through the actual proof again. So given angle 1 is congruent to angle 2, I'm going to put that in my proof spot. So angle 1 is congruent to angle 2. And this is our given. And right here, I'm going to go through everything, all of the steps so that you can see what this looks like. All right. Angle 1 and angle 2 are supplementary to each other. Well, I know that because they are a linear pair, right? So I know that angle 1 and angle 2 are a linear pair. And if they're a linear pair, that means they are supplementary. So this is the linear pair postulate. Come on. So frustrating. So this is the linear pair postulate. All right. By the definition of supplementary, I know that that means two angles have to add up to 180 degrees. So if two angles add up to 180 degrees, that is the definition of supplementary. Right? Now here, I know that angle 1 and angle 2 are congruent to each other. If angle 1 and angle 2 are congruent to each other, then if you notice from step 3 to step 4, notice how I'm just plugging in angle 1 where I saw angle 2 before. This is substitution. I know this is a blast from the past. This is something that you guys feel like you haven't seen in a very, very long time, and that's okay. The next one, notice how it goes from angle 1 plus angle 1 equals 180.
Supplementary too.
Say it again.
Supplementary as well.
Nope, that's close. But if we see, we have angle 1 and angle 1.
Substitution.
It is not substitution. That's what a lot of people want to say. It's actually So we have two angles being added, and instead of adding the two angles together, I'm saying I'm multiplying two angles together. It's the same exact thing. So 2 times angle 1 and angle 1 plus angle 1 is the same thing. The exact same way that 1 plus 1 is 2, and 2 times 1 is 2. It's the same thing. So now if you look here, what's going on? I'm going from 2 times angle 1 equals 180 to angle 1 equals 90. I'm dividing both sides of the equation by 2. So that's division. Angle 1 is 90 degrees. That means that angle 1 is a right angle. So this is the definition of a right angle. And then finally, line A is perpendicular to line B. This is the definition of perpendicular. All right, so that's just another example of a proof. That's just another example of a proof, something that you guys can kind of see and hopefully make your way through. I don't know that I would expect you guys to be able to do this right now on your own, but it definitely is something that you should be able to look at and go, okay, I see the steps that he's making there. I just don't know that I could do it by myself. And that's fine. No big deal. All right. So let's go back and we'll look here. So this is another proof, another method of showing a proof, another method of something being true or untrue. And we hopefully are just going to kind of work our way through and see how the proof really works. So this one, again, this is another thing in your book that you guys are going to be able to see. And I want to make sure that I use the same wording as your book uses. Give me 1 second, I'm thinking. 1 minute. Here we go. This one is if two sides of two adjacent acute angles are perpendicular. Nope, sorry. Yes, if two sides of two adjacent acute angles are perpendicular. So what that means, this is AB and BC is what it's talking about. See how angle 1 and angle 2 are adjacent? They're touching. So angle 1 and angle 2 are adjacent. They are touching. AB is a side of angle 1. BC is a side of angle 2. So if they are perpendicular to each other, then that means the angles are going to be complementary. Now this should be common sense. If I'm telling you that ABC is a right angle, that's what I'm saying. If AB and C are a right angle, then that should mean that angle 1 and angle 2 add up to 90 degrees. That should be a no-brainer. That should be something that you look at and go, yep, that's not surprising at all. I know exactly what's happening. If I tell you that ABC is a right angle, that means that angle 1 and angle 2 should add up to 90 degrees. That's what this is saying. Okay? Now, that being said, this is just another proof that we can work our way through. So hopefully with this proof, you're good. Huh? Your text? No. What do you need? The mouse? So this being said, this should be kind of a common sense idea. If it's, oop, I don't know how I got muted. Am I muted right now?
Nope.
I just got a message saying that I was muted. That was weird. But anyway, if these are a 90-degree angle, that means that angle 1 and angle 2 should add up to 90 degrees. Pretty straightforward. So right here at the very beginning, I am given that AB and BC are perpendicular to each other. That means I can put a right angle mark right here, just like I did. So in my proof, I'm going to do AB is perpendicular to BC. So AB and BC are perpendicular, and this is given. All right. So there is my given statement. Should be a pretty straightforward statement. If it's not, make sure that you ask me to kind of clear it up, or I'll try to clear it up any way that I can. Angle ABC is a right angle. The reason that I know it's a right angle is because I know the word perpendicular means that two lines cross at a right angle. Okay. This one says that ABC is 90 degrees. ABC is 90 degrees. That is because this thing is a right angle. Okay. Now this one is tricky. This one is like one that I would put a little star by because this is one that people are going to mess up over and over. Excuse me, and over again. Angle 1 plus angle 2 equals the whole thing. Angle 1 is the small angle. Angle 2 is a small angle. Angle ABC is the entire angle, the big angle. So this is the angle addition postulate. So this is the angle addition postulate. Okay. Now using substitution, I know that angle 1 and angle 2 add up to something. They add up to ABC. I know up here that angle ABC is 90 degrees. This is substitution. So I'm going to put 90 degrees right there. And then finally, angle 1 plus angle 2 equals 90 degrees. I'm going to put here angle 1 and angle 2 are complementary. So they are complementary, and that is by the definition of complementary angles. All right. Again, this is not necessarily something that I would expect you to be able to do perfectly, but I definitely expect you to be able to watch this and say, okay, I see where those things are coming from. I see where those words are coming from. I can see what's happening. I just have to be able to figure out how to put those things together. All right. So that's what I'm expecting of you right now. I'm expecting you to try to be able to put those things together. Okay. Now, the last thing that I want to do before I kind of send you off on your way is I want to try and find these words. Okay, I want to try to go through these things so that way hopefully we can kind of understand and see just a few more definitions. The rest of this worksheet, I don't know why there's a blank page in there. The rest of this worksheet is just you trying to figure out when things are congruent, when they're not congruent, whatever, and we will pick up that stuff tomorrow. All right. So we're going to go through these three things right here together.
What was number 6?
Just a second, I'll go back. You good?
Mm-hmm.
Okay. So let me get this pulled up. Okay, so this one is pretty straightforward. If two lines are perpendicular to each other, then they intersect to form 4 right angles. Which means that if I have a, oops, that was a bad line. If I have a line here and a line here and they're perpendicular to each other, it should come as no surprise that this, and this are all right angles. If this angle is a right angle, oops, okay, how do I turn that off now? If this angle is a right angle, that would mean that this angle is a right angle, which would mean that this angle is a right angle, which would mean that this angle is a right angle. Because if these two angles add up to 180 and this side is 90, this side has to be 90. If this side is 90, this side has to be 90, and so on. So if two lines are perpendicular, then they are going to intersect to form a right angle. Okay? The perpendicular transversal theorem. In a plane, if a transversal is perpendicular to one of two parallel lines, then it is perpendicular to the other line as well. Okay? Now what that means, let me draw a picture of it. So I know that I have a parallel line and a parallel line. I'm saying those two lines are parallel, and then I've got a perpendicular line. Now, if I'm told in my picture, if I'm told that this line right here is perpendicular, let's say I'm told that thing right there is perpendicular. Well, if I know that these lines are parallel to each other, then based on all of the other things that I've ever used, alternate interior, alternate exterior, consecutive exterior, corresponding, I know that this is also going to be perpendicular. If I know that both of those are perpendicular, then that means that this line is perpendicular to both of those lines. Okay? Now this one is just the exact opposite thing, where it says in a plane, if two lines are parallel or perpendicular to the same line, so if they're perpendicular to the same line, then the lines are parallel to each other. So like for this, if I know that I have a, oops, if I have a line like this, and then I tell you, okay, I know I have a line like this and a line like this. If these lines are perpendicular here and here, then I know these lines are going to be parallel to each other. That should just be common sense. It's something that the book feels like you need to know, but it should be common sense to look at. All right. If I know that two lines are parallel to each other, then they should be perpendicular to the same line as well. If there's a line that's perpendicular to both of those two lines, then obviously it should be parallel. Okay. So let me just kind of walk through and talk through what I expect from you on this, because right now you've got about 10 minutes. So I kind of expect you to use that time to do something. All right. So with this one, I'm just trying to figure out a theorem or a property or something that's going to justify that that angle is a right angle. So maybe just use your words. I don't even care what you do. Just use words to try and describe how this works. In a proof, I don't care if your words are exactly correct or not. As long as you have the general idea, I'm good with that. Okay. So as long as you know kind of what's going on, that's fine. All right. So if I look at this, it says angle 1 and angle 2 are right angles. I have to prove whether that's true or not, or find something that proves why it's true. Okay. So this one, I see that I have this angle and this angle right here that are right next to each other. 2 and this angle are right next to each other. And they're both the same, right? Because they have to both be 90. So if they're both congruent to 90, this is the linear pair, the first one that we did. And the reason it's a linear pair perpendicular theorem is because angle 1 and angle 2 are a linear pair. And I know that these lines are perpendicular. Linear pair, perpendicular. Put those things together. Oops, I just turned that into a 4. Linear pair, perpendicular. This one right here, I'm told that A and B are perpendicular to each other, and they're a linear pair. This is, again, a linear pair, perpendicular theorem. This one, angle 1 and angle 2 are complementary to each other. Well, that's just the second theorem that we did together. So if you wanted to go to your front page and put like number 2 or second theorem, you could say, you know, two angles add up to 90. I don't really care what you're doing with these. Just kind of try to run through and say exactly what you know. Try to run through these and describe what's happening. With C, I want to try and show that line C and line B are perpendicular. Well, I know that line A and line C are parallel. And I know that A is perpendicular to C. So if I know that A and B are parallel to each other, and A is perpendicular to C, I have two parallel lines. One of those lines is perpendicular. So if I know that one of those lines is perpendicular, this is going to be the perpendicular. Let me just do this. I can't write on this thing. So this is the perpendicular transversal theorem. So this is just what I'm asking you to do. I'm not expecting you to be an expert on these at all. I'm expecting you to just kind of run through and be able to explain what's happening with your words. So be able to look at a picture and say, oh yeah, angle 1 and angle 2, if those lines are parallel or perpendicular to each other, I can tell this and this about that. If I look at two angles, I should be able to tell this and this about that. That's what I want you guys to try and do for the rest of this page, all right? So for the rest of this page, just try to explain what's going on. I don't really care what the theorems are. See how it says theorem and or explanation? I don't care what the theorem is. Use your ideas, use your thoughts to come up with something. Use your concepts, your ideas to try and come up with some form of reason or explanation as to why those things are congruent, why they're parallel, why they're perpendicular, whatever. All right? That's what I want you guys to try today. We'll pick up on that tomorrow and go through that a little bit more tomorrow. I'll also have a practice test for you tomorrow that you can attempt. And that being said, then we'll kind of run through and get ready for our test on Wednesday.
What's the practice test going to look like?
The practice test will look the exact same way that it has on all of the other ones on Big Ideas.